Capacitance. So the first one, capacitance of 20 microfarads. So capacitance 20 by 10 to the minus 6. Calculate the charge on each plate. So the charge, Q is the charge on each plate. Okay, so that's Q, potential difference of 500. Okay, so for part 1, okay, so we see is Q over V. Capacitance 20 by 10 to the minus 6 equals Q over 500. And rearranging and multiplying, you get a value of 0.01 coulombs. Okay. Part 2. The net charge in the capacitor. Well, remember the net charge in the capacitor is always 0 because there's a charge of plus 0.01 on one plate and minus 0.01 on the other plate. Remember, in a capacitor, the charge is redistributed, not made. Okay, so the capacitor charge is redistributed. So the plus charge on one side, minus charge on the other side. So the net charge of the capacitor is always 0. Part 3, the energy stored then. There is an energy stored because of that redistribution. The same way as you'd have an energy stored if you put a book higher on a shelf. Okay, so it's a half by the capacitance, 20 by 10 to the minus 6. By the V by V 500 squared. So you're just filling this formula in and you get a value of 2.5 joules. There you go. Okay. Question 2. Parallel plate capacitor consists of 2 rectangular overlapping plates of dimensions. Okay, so this is a parallel plate capacitor. So always, if you're doing that, remember step 1. This is what you're interested in. So we're interested in the area, common area of the plates. And we're told they overlap and they have dimensions of 20 meters by 0.02 centimeters. So we might as well work that out over here. We've changed 2 centimeters, 0.02 meters, and we get a value there of 0.4 meters squared. Permittivity. Now, permittivity on page 46 is permittivity in a vacuum. If you're given a relative permittivity, you just multiply that permittivity by the relative permittivity. So it's permittivity relative to the permittivity in a vacuum. And again, we might as well work that out here, and we're getting 2.14 by 10 to the minus 11. The distance between them, the plates, is the thickness of the dielectric, so that's 4 by 10 to the minus 3, or 0.004 if you'd like. And to get the capacitance, now we're in business. Okay, so it's 2.4, my mistake, it's 2.14 by 10 to the minus 11 multiplied by 0.4 divided by 4 by 10 to the minus 3. Okay, let's work that out. Sorry, so 2.14 exponential minus 11 multiplied by 0.4 divided by 4 exponential minus 3. Okay, and we're getting a value of 2.14 by 10 to the minus 9 farads. And remember, 10 to the minus 9 is just nice and handy. It's 2.14 nanofarads. So 10 to the minus 9 is nano. The last part, part 2. Okay, what is the new capacitance? The distance between the plates is doubled. When you get something like this, you need to be able to use your proportionalities. So in this case, capacitance is inversely proportional to the distance. Okay, so if you double the distance, the capacitance halves. So the new capacitance is 2.14 divided by 2. So the capacitance is 1.07 nanofards. There you go.